Welcome to General Structures 2 and Lateral Forces, Lesson 3, Example number 3. And it is asking us to graphically determine the forces in all the members of the truss in Example 1. So here is Example 1. What we've already done is we've gone ahead and figured out what the reactions are. So now we need to just go back and figure out graphically how to figure this out. And I have, just to let you know, I have never done this. I was never taught this in school, this graphical solution. And maybe it's something you want to go about. Maybe with some practice it would be a little bit more intuitive, but right now for me it is non-intuitive. I'd rather just do the method of sections or method of joints or anything else, because this graphical solution, I've never done it before. So maybe I'll look into it a little bit more and I'll end up loving it and use it quite often, but right now I do not. So what I'm going to go ahead and do is go through how to do the graphical solution, and hopefully you can decide for yourself whether you like doing it or not. So what you want to do is you want to start with A. You come over to the side, you want to start with your reactions, your external reactions. So we're going to start over here, and this is A. And you use your, once again, your external reactions or your external loads. You start at A and you go down. Hold on. And this is at scale. Obviously I'm not doing it to scale, so I'm just going to give you an overview. Actually went and used the drafting program and did it to scale, and everything did work out the way they said it does. So go ahead and just go through the study guide. But anyways, here we go. So we start at A, and A, B. So you kind of confusing, but you start here at point A. So you can say, okay, or not point A, we'll say member A, and then you go down 3,000 to get to B. So down 3,000, let's say that's 3 to get to B. Then you go over here and you go down 5,000 to get to C. So that is a total of 8,000. That's 3, that's 4, that's 5. That sounds good. And then I'm going to switch colors because this is where it gets a little confusing. Now you go over here from C to D, you go up 4,500. So we just went down 5,000, so it's going to be about right here. And I'm going to put it slightly off, but it's supposed to be right on. And we're going to get to D. So we go from C, and we go up to D. And then you go the rest of the 3,500 back up to get to A. So I guess this is kind of DE right there. Hold on, let me see. This whole side is D, and so this E does not exist. Get rid of that. So you put these, the A, B, C, and D between the loads. And I would love to do this in the future and see how it works out. See if you can do it for large, very large, complicated trusses. So to get from D to A, you go 3,500, and that should bring you back up here to A. All right, so you're back up there. That's how you started. Now, from there, you say, hey, okay, what do I do now? And the first thing you want to do is look at these 1, 2, and 3 inside your triangles, and you want to say A1. A1 is like that, so what we want to do is transpose this and come down at that same angle, which that is a 45-degree angle, since that's a 90, so half of it would be 45. So you want to come down to that 45-degree angle. And then you want to take a look at D1. So D1's right here, A1's right here. D1, so you start at point D and you come out, so this is D, and you come out at the same angle that this D1 is at. And where you connect, you call it 1. So this is the angle of A1. This member is kind of A1. A because there it is, and 1 because it's in the middle. And D is this side, and D1 is because 1 is in the middle. And this is 0.1. Let's actually put 1 below that so it works out better. Alright, and now if you would actually go out and measure this, you would get the distance. This would be 4.95 whatever units, and therefore it would go to 4.95 kips. I'm going to get rid of that for right now. Alright, so there we are, and then we want to continue that same thought process on. You have B2, so B2 starts, B is right here, and 2, so B2 comes out like so. B would come out like that, and then to get to B2, you look at the intersection, what would work? It would kind of be 1, 2. 1, 2 is right here. So 1, 2, you go from 1, you go to 2. And I see how that's confusing how to get there. See B2 and 1, 2. This is 1, 2 right here, since this is both interior. And this will be, remember, 2, 3 right here. So I guess we go ahead and do that right now. Remember, 2, 3 looks like that. So we come down like this. Now what else is going to 3? We have, remember, C3, and therefore we want to come up from C3, and it would come up something like that. It would match right here. So that's your point 3. And I believe that is all you need to do. Actually, no, we're missing one. If I'm taking a look right now on page 68, seeing what the shape they have, it looks like it's similar, but I'm missing this piece right here. So I'm going to go ahead and switch colors. So I'll just go with yellow. And we're looking for 3. So we have what? We have C3, which we already did. And then we have D3, which this is D3. And D3 comes out like so. And it hits right there. So there's your D3. D1's up there to 1, D to 1, and then D to 3. So you can see that D3 has a little bit higher load than D1 does, and that kind of makes sense because you have a higher load above D3 than you do D1. So that is your I'll call it a stress diagram. I guess that's what they call it as well, a stress diagram. And if you go in here, and obviously if you had it scaled correctly, you could mark out and you can measure these and say, alright, this is 6.35. If you did it 1 inch equals 1,000 pounds, then you would say, oh, this one equals 6.35 inches, and therefore you equals 6.35 kips. And I would only do this if you have an exact CAD program. I would never do this by hand. Or at least you could, I guess you could do it if you have calc paper, but even then, if you can draw, or to the nearest hundredth on calc paper, then you're a better man than I. So I would never go about doing this in this way simply because of that. But it is an interesting exercise to go through to see what would work out, and you can measure all these out, and it does work out, which maybe one of these days I'll do a video on why this works out the way it does, this stress diagram, and we can go in the ins and outs when I do that video. But right now I'm not going to, because I do not have the necessary tools. That I want to go ahead and do this because I've never done this, and they never taught this in any of the classes I did, so there must be a reason they did not teach this, a stress diagram, in classes. Alright, but that is how you do it, and hopefully that makes sense. You kind of just go from point to point. You have A to B, and that's AB is negative 3,000. Then you go from B to C. BC, you go negative 5,000. And you go from C to D, and you went up 4,500. And you got the point D, or member D, however you want to call it, side D. And then you went up from 3,500. So you got your original line of lines over here. You got your original points. And then from there, you take a look and you say, okay, A 1, and you start at A and you go down the 1, and it has that same angle that this has. And then you also say, okay, what else goes to 1? Well, you have D1, so you could say D1 is right there. So you go from D to 1. And then you also have 1, 2, and you go this angle 1 to 2. It matches. You can see how it matches the same perfect degrees. And once again, if you're freehanding this, that's assuming, let's say you have something that looks like you have some nasty degrees like 36, 36. I don't even know what else this would be. What does that make? 72. Well, so that's what? 98, I believe. I could be horribly off. Anyways, you have this type of triangle, and you're trying to graph these to match that angle perfectly, and you're betting that you're matching it perfectly, so that dimension will be correct and that angle is correct. It just gets to be a mess. Once again, if you have a drafting program or a CAD program and you want to do this, I'd see no problem with it whatsoever. So I've beat that horse dead, and I'm going to go ahead and stop the video. I will see you on the next exercise, and good luck with this.